Hello everyone and welcome back to our second masterclass. We have with us once again Mr. Ashutosh Meher, Developer Evangelist R3, bringing us the second masterclass for the day, Introduction to Confidential Computing with Conclave. I would request all the delegates to please keep posting their questions in the chat box and we will pick a selected few towards the end of the session. Over to you, Ashutosh.
Thank you, Aparna. Thanks for having me here for for talking about Conclave, and thanks to the entire IAMI team actually to organize this kind of summit and help us share information about different platforms. So thanks everyone for joining me today. My name is Ashutosh, as Aparna mentioned, and I'm a developer evangelist at R3. And what we do is we take care of helping developers to onboard and also to develop applications on our different platforms that we have. So one of them is Corda. We had a masterclass earlier today. And then the next one we're going to talk about is Conclave. So let's move on. Well, before we get started, here are a few references which will be really helpful for you as you start exploring more about Conclave. So first and most important is the official documentation where you'll find anything and everything about Conclave. So that's docs.conclave.net. And if you know about R3, then you might know that we have a product called Corda, which is so we have a community over there, which is on the public Slack, slack.corda.net. And we do not have a separate Slack or a separate community as such defined as at this point of time for Conclave, but we might think to do it. But at this point of time, if you want to discuss anything about Conclave with the community and with the developers or with someone at R3, then you might just go over to the public Slack, and the channel that you would be interested in is #conclave. And the team also put forward a lot of blogs and stuff which you might find interesting. So do have a look at that at our Conclave blog site. And then you want to reach out to the developer relations team, which consists of me and other members. Then it's the email for that is r3devrelations@r3.com. And if you like to tweet, then the handle for Conclave is @conclavecompute. All right, so with that, let's move on and let's talk about confidential computing. So first of all, the first important thing that we want to understand here is what is data? And as you might know, right, data is the new currency. That's what we really say at this point of time. It's really very valuable because we have been utilizing data to do a lot of different miraculous stuff, right? Over the years, we have used data to produce to great effect and it has actually given a lot of benefit to humanity. But with this, because data is so important, it's really also important for us to actually protect that data from misuse. So there are different ways of protecting data. If you think of data, it can reside in three different states, right? One is data at rest, just lying around in some hardware or something. So there, and then there is the other way, that other state of data, which might be data in transit. So this is where your data is moving from one system to another system or through a network, right? The last one is the data in use, which is where the data is actually getting processed in some processing unit, right? So the way we protect data is for data at rest and for data in transit. It's pretty much, we have a lot of different ways of doing that. So one of the ways for protecting data which is at rest could be using hardware encryption, which will not allow unauthorized access to it, and also have different kind of protection policies, security policies for data at rest and also for data in transit. So one commonly used way of protecting data while it's transiting over a network is to use TLS, which again uses encryption, right? So there are different ways. There are different sort of policies and stuff which are used to protect data at rest, and data in transit. What about data in use, right? So we never talk much about protecting data when it is in use, though it is of utmost importance. So one of the fields that has been coming forward in the recent time is to protect this kind of misuse of data while it is in use. That's what we call as confidential computing, right? And Conclave is a platform which also helps you with protecting data that is in use. So when I say protecting data in use, let me bring to you an example, which a very simple example. So say, for example, you have a company which is coming forward and putting an RFP for a particular project, right? Then there are different people who would bid for that project, or different organizations who would bid for the project. But they're actually at the mercy of whoever is handling the data. They might put their bids, which is supposed to be confidential, but someone has to see it and able to process it, right? Someone has to go through all the data and find out which is the best proposal. But so the organization who is handling all this data, you're at the mercy of that organization, that it would not do anything goofy, and it would not really share your data or use that data for their own advantage, or share the data to some of your competitor for some benefit of their own. So who is protecting you from that? To help us with that, that's where confidential computing comes into play. You can send data secretly to a system which will process your data secretly as well. And even if even the operator of the system will not be able to read that data or tamper with that data. That's the power of confidential computing and Conclave. Right. So what is confidential computing? Like we said, it's a way of protecting your data while it is getting processed. So you send your data in an encrypted format to a particular system which will process your data, and it will send you the results without anyone actually looking into that data. So there is no physical interaction with that data while it is getting processed, or in terms of no human interaction, I should say. So this is done by a specific technology called Enclave. So data is processed inside an enclave. And what exactly is an enclave? Well, it's a secure region of memory, you could say a special region, which is blocked to anybody else apart from the CPU. The CPU basically blocks access to that particular region of memory, even to authorized softwares like your BIOS, or even the kernel. So they can't really see what's happening in an enclave. So they can't really see the data, so they can't even temper it. So that's where even the host machine, which is actually processing that data, which is having that enclave within it, is not able to see that data. So that's how your data is protected from unauthorized use, because no one can see it, no one can temper it, right? All right, so that's confidential computing, but what exactly is Conclave doing with that, right? So Conclave is a simple toolkit, I would say, which will ease your development of the enclaves. So these enclaves are special programs which you'll have to write, and then that program has to be loaded onto that special section of memory for it to get processed, and any unauthorized access will not be allowed. So Conclave will help you to write all those kind of programs with a high level language, which is like Kotlin or JavaScript, even JavaScript, or maybe Java, or any JVM compatible language, plus JavaScript, which, because we use GraalVM and it supports JavaScript as well. So in a way, it's a JVM inside an enclave, and it does require hardware support. So Conclave will require support from Intel, which is Intel SGX hardware. So we build on top of it, and the hardware that Conclave supports is Intel SGX. So SGX is responsible for protecting your enclave and creating that memory space, which will be basically blocked from other unauthorized access. Right. So when you develop a Conclave application, what are the different components that you really develop, right? So let's talk about that a little bit. So the first thing that you need is the enclave. As I mentioned, it's a special program which will take care of processing your data. So it's just looking at processing your data. You don't really have heavy programs written onto there. It should be as small as possible, and its only job is to just process your data. Your data will be sent there, it will process it, and it will send back you the result. And then you might have a host, or basically you would need a host. And this is the program which is basically loading the enclave onto your loading the enclave program onto your protected memory space, which is the enclave. And then it also serves as a proxy between your client and your enclave. So and this host, it is supposed to be untrusted at all the times. It should not be trusted. So all the communication between the host and the enclave has to be encrypted, right? So the last part that you'll need to develop is the client. Obviously, the client, which will basically, your end user will interact with the client to send data to the enclave via the host. So generally, confidential data is sent. So you might use any kind of an API to interact between the host and the client. Generally, So for an example that we will have today, we'll use simple TCP protocol, but you might want to use something more sophisticated like a gRPC or something. It doesn't matter. It's up to you what kind of a protocol you really want to use. But the idea is to encrypt the data and send that to the host, which will then send it over to the enclave. So even though the entire data is sent to the host and the host forwards it to the enclave, the host will not be able to do anything with that data because it's actually encrypted, and that data will be encrypted using special keys. So whenever a client sends data, they will have they can generate a public and private key pair through which they will sign that particular data and then send it over so that the host cannot really tamper with that data. And then the enclave can just go ahead and process that data. And while sending back the result, the enclave will also encrypt the data using its private key. And then the client will be able to decrypt the data to see the information or the processed information. And finally, we have a unit testing module, which will help you to do sort of testing of your code. This unit testing module is also provided as a library with the Conclave with Conclave with the Conclave programs, so you can easily do unit testing of your codes as well. So generally, if you look at this diagram over here, the way it works is you have these three different components, which is the enclave, the host, and the client, which we just talked about. So the client will send encrypted data to your enclave and to the host, and the host will then forward the data to your enclave. And similarly, the processed data can then come back to the client via the host. So there are two important things here as well, which is the remote attestation and the enclave assessment request. So we'll talk about the remote attestation after this and the enclave attestment request as well. So remote attestation, just to give you a brief idea, is a way to identify whether the enclave is authentic or not. And once you have that information about authenticity of the enclave, you can actually then go ahead and ask Intel using their services to give you an assessment report whether that enclave is still considered safe or not. So Intel can give you that kind of an information, right? So let's talk a bit more about remote attestation. So it's all good that we have an enclave and I can send data to the enclave to process my data in a confidential manner, but it's just a matter of having a key pair, right? So what is basically preventing me from just having a normal software, which is, or just a general system, which is basically having a key pair and then sending that information to you? How would you really make sure that the enclave is actually an enclave that it's talking about? So that's where the remote attestation actually helps you. The remote attestation is a special piece of data which will have different sort of information which will help you identify whether that enclave is authentic or not. Or it will also let you know whether that particular enclave which is telling that I'm going to do X with your data, or I'm going to process your data in a particular manner, it is actually doing that. So that the remote attestation will come with a special code hash, which is called as a measurement. And what that gives you is a special hash. It is not just a general hash, which you can, which you can just generate. It is generated using a special tool, which will basically take the entire enclave module, which is along with the dependencies as well, which is then loaded onto the enclave's which is then loaded onto the special memory space. So that is the hash, and it's designed, so Conclave is designed in such a way that multiple build of that particular file or of that particular piece of code, if it's the same code, will produce the same code hash. So what that means is you can always go ahead and ask for a remote attestation from the host. And once the host gives you that remote attestation, before you send your data to the enclave, you can actually verify whether it's the exact same enclave that you have been told, and it's not anything different, it's not doing something different. So this gives you a way of identifying what actually is going to happen with your data. So the way that your data is going to be processed is going to be known to you before you send your data to the enclave, right? Now, because we are utilizing a hash which is derived from the code base, which will be running on the enclave, so this might create a problem when you basically upgrade, right? So basically, when you upgrade your application that's running or your program that's running within the enclave, what that means is that since it's not the same code base anymore, your attestation is going to change, which means your measurement is going to change. So how do we take care of that? So one way is to basically have different whitelists. So you can just check your measurement with a list of with a list of different hashes which you have whitelisted, and that would be one approach, and to basically protect against upgrades. But what as an alternative, which would be even better, is to use a signing key or a list of signing key, which you would allow or which you would accept. So once your Enclave program is signed with that particular key and loaded onto the protected space, and then your remote attestation gives you that particular signature which says that the Enclave program is signed with this particular key, then you could say that, well, I will accept this particular I will accept this particular Enclave program, and I'm ready to send my data. I trust this particular program, right? So those are the different ways of managing your Enclave so that you don't have issues with upgrades, right? So remote attestation is actually a very powerful thing which will help you really identify what's actually happening with your data and how the way your data is getting processed actually. I think we have a question here. All right. Is remote attestation similar to verification in blockchain? It's sort of like the same. So it's if you are familiar with Coda, we use a similar sort of technique where we identify whether a contract is right or not, whether a contract is is the correct version of it or not. We use contract constraints, which again uses signing keys and whitelisting. So it's not exactly same, but yeah, on the similar lines, I would say. So it's just giving you an idea whether the program that you're sending your data, or the Enclave program that you're sending your data, is authentic and it's not doing something different. So say if your program says I'm going to process your data in a particular way. So for an example, if I'm going to send my data to say an auction program, which is actually having a code which will select the best bid based on the lowest amount or the highest amount, whichever you might have, whichever you might choose in your program, the kind of auction that you're doing. So you can produce a measurement of that program, which will give you a special hash, and you can then check the hash, which your host can provide you, that the program running within the Enclave is actually having the same hash. So it's a way of verifying that whether your Enclave is exactly what it says it is. Right. And then whether it's really an Enclave or not, or is it just a program running in a normal place, you can actually go ahead and check with the Intel services where it will, to see if your code hash or your attachment or your remote attestation and a measurement that you have received. You can send that information to Intel using their services, and they'll tell you whether this is a secure Enclave or not. All right. So coming back to Conclave, so one of the important thing is to how do we send data, right? So Conclave makes it easy for you to handle this kind of thing. So it provides you with something called as the Mail API. So what it does is it enables you to have end-to-end encryption between your communication for the communication between your client and your Enclave, right? So it has so this encryption is basically an AES encryption, which is which again uses the Enclave secret keys. So you generally know that when you get an information from somewhere, you know that it's actually the Enclave which has sent you the data. It's not someone else pretending to be an Enclave, because the remote attestation will also have the public key of your Enclave, which you can use to verify that the information that has been sent is actually signed by your Enclave, and you can verify that yes, it's the correct data. And the Conclave Mail API also provides you with certain tamper-proof headers, which is unencrypted, and it could be used by your host for various different things, like for ordering your information or for sequencing your messages that you're sending. So all these are tamper-proof but unencrypted. So you can manage different workflows using the host. So something like, say, you want to have some sort of process through which you'll manage through headers, something like billing information or something, right? So that could be done with these headers, which the Mail API provides you. And it also provides you with or it prevents you from dropped messages or messages arriving in not in different orders. So basically all your messages that are sent using the Conclave Mail API will have a topic, which is like a random string, which you could choose. And then you would have a sequence number so that your host would know which messages should come first and what are the order of your messages as well. So Mail API helps you with all these kind of things. So it's also really easy to create your mails or to send information, encrypt it, and do all this stuff. So you just have to call the APIs and it will do all that stuff for you and then send it. And sending this data will will really become easier while you're working with Enclave. So generally with Enclave, with Conclave, basically it makes your entire job of defining and running this or building this entire applications very easier, because if you directly work with the enclaves, which is like the hardware part of it, it will be really tedious because it has to be written in low-level languages and it's really tough to work with them. So Conclave provides you with an opportunity to basically use high-level languages like Java and stuff, which makes developer lives a lot easier when they develop their applications on Conclave. Right now, as we have already talked about it, right, we require specific hardware support. So how do we develop it unless we have, how do we develop different applications unless we have this specific hardware on with us, right? Do we have to purchase a new hardware or something? So generally, Conclave allows you to run your enclaves in multiple different modes. So the different modes that we have are, first, these are all in the decreasing level of security. So basically the first one is or the most secure one is your release mode, which is supposed to be used in production. And it requires obviously the specialized hardware, which is basically Intel SGX, and it provides your protection for your enclave. So whenever you're in production, you should be running on release mode so that the enclave is properly protected using the SGX hardware. And then the next one, which is a little bit less secure than the release, is the debug mode, which is basically similar to the release mode, pretty much similar, other than the fact that it has a backdoor which will allow you to debug onto the enclave. So it could have, so it's insecure because it allows you a backdoor, obviously, but it could be something which is pretty much helpful for you when you want to debug your application, probably something like a UAT environment where you want to run it pretty much almost equivalent to your production environment, but then you still want to debug your applications for any potential issues or something. So that's where debug mode would be helpful. And then we have simulation and mock mode. The simulation is is also less secure than debug. It doesn't have use in SGX hardware itself. What it does is it uses software simulation of SGX, and it does require specific OS, which is Linux. So you have to use Linux, or if you're on a Windows or Mac, you can actually use Docker to run your Conclave on simulation mode. So it's insecure. It's also good for development. You could have the feeling of SGX, though you're not having the Intel software or the Intel hardware installed, but you can still basically do your development stuff. And the last one is the mock mode, which is no SGX at all. It's pure Java. Both the host and the enclave are loaded onto the same JVM. So one point to note here, or probably worth mentioning, is the host, which basically runs your or loads your enclave. They're not really running on the same JVM. There's two different JVMs, right? One JVM which is running inside the enclave, and then the normal JVM which is the Graal VM basically, which will be running in the enclave, and then the host will be running in a separate JVM. So there is no sharing of JVM in release, debug, or simulation mode. But for a mock mode, it's basically just normal Java development. There is no enclave, there is no SGX. It's pure Java. They use the same JVM, and that's also pretty much helpful if you're doing development. All right, so that's what I wanted to share about Conclave. Now let's see some of it in action and see how things work really in Conclave and how easy it is to build applications on Conclave. All right. Okay. So like we said, we have three different modules for building your Conclave application. So you will need the client, you will need the enclave, and you will need the host. I also have a common module, which is for some common stuff, which is like some models and stuff, which I'll be using in the programs. So let's look at the enclave first. So this is my enclave. For creating an enclave, you obviously extend the enclave class, and that will help you build an enclave. And all you do here is just have your processing logic. So what this is an auction enclave. So basically your auction, you'll send different bids to this enclave, and it will process those bids depending on whoever has the highest bid is going to win your auction, right? So this is where we are having all the information. Just the processing bit, the processing kind of logic is required here. Receive mail is the method which your enclave will provide. So any mails that is sent from the host, from the client to the host, and eventually from the host to the enclave will be received over here, which you can just go ahead and read mails, which is a method here. So we use so obviously it's coming from a network, so it will be serialized. So we'll have to deserialize them and then read your information from the enclave, from the using in the enclave, and then use that information to process the data. So all it's doing is processing the data, and then here we are sending some results back to our what I would say the clients. So the way we identify which client we should send the results to is we are keeping we provided with a route or a user route, which is basically a string which will help you identify. So every client that sends a request will be assigned a special string, and that string will be used again when you need to basically send any information back to your clients. So it doesn't know who the client is or anything about them, but it does know that there is a client which I need to send the result back using this particular route, right? So it just has that particular logic which will be responsible for processing your bits. And then you have the host, which is basically your program with that will be serving as your middleware between the client and your enclave. And it's also responsible for loading the enclave, right? So what you will see here is initially what we're doing is we're verifying the support for the platform. This is where we verify if wherever the host is running, is that even support, is that platform supporting enclaves or not. So this will again depend on the support will again depend on what mode you're running. So that if you have the correct mode chosen, then it will give you the correct response. And then the next thing, once you've verified that the platform is fine, you can just go ahead and initialize the enclave. So as I said, the host is responsible for loading the enclave. So this is the enclave class which I want to load, which is my auction enclave. And when I go to initialize enclave, what it generally does, it just initializes your enclave using the load method. And it has a sort of a callback. So any response that your enclave will provide you will be accepted over here, and you can then send that response back to your client using the routing hint, right? And finally, we're starting a TCP server to serve to requests from the client, which is basically the server socket and stuff which is done over here, right? And finally, we have our client, which will be sending out information. So initial bit is pretty simple. We're just first thing we're doing is establishing a connection, which is just a TCP connection. And then here is where the things happen. You're getting the attestation, and then I think we must be printing the attestation somewhere. Yeah, here's the attestation info that we're printing it. So basically, for a normal application or a production type of application, what you will do is you'll verify the measurement and then verify whether using some service or something that you might have written, and then basically see if you're safe to send your information to the enclave or not. But for the purpose of this demo, it's fine to just print it out so that you know how your attestation really looks like. And I'll show that while I run this particular application. And then once we get the attestation, you are going to get the user input or the user bids. So we're using the console to ask the user for their bids. And finally, once you have the bid, you are going to serialize that and create a key to sign your data and send it to the enclave using your. So there is a function or a special API called the Postman API, which will help you create mail objects. and this will basically also help you encrypt your message, sign your encrypt and sign your messages and send it to the to your host for processing, and the host will basically send it to the enclave, which is pretty much simple. And then once you receive your information back, you are going to decrypt it using the same post office, and then that will give you a reply which you can guess, which we have just again gone ahead and printed it onto the console, right? So let's just go ahead and run this program, and let me show you how this thing really works. So as I'm on a Mac, I would not be able to run it on my machine. So I'm using Docker to run the host and the enclave, and the client I can run it on my on the host Mac machine itself. Right. So first of all, what I need to do is go ahead and run Docker. Here is the command to run Docker. All right. I'll just go inside the host and start it. Okay, so my host program is running and it's listening on port 5051, as you can see here. Now I should be able to run my client. So I'll again use the so the way I'm doing this is what I'm doing is for the so there are two different type of messages that I will be sending, right? One is the actual bid, and then there will be a trigger to process the bid. So whoever is the admin of the auction, I would say, would tell the enclave to process the bids and finally give you all the information about who the winner is, right? And then send back any information to all the bidders, whether they have won the auction or they haven't won the auction, right? So you could have multiple instances of clients running, which will send different information to the enclave. So then I'll first start with one client, right? So what it does is, here is your remote attestation information that I talked about. So as my client connected to the host, what I have done is I have so for what I've done with the host is, as and when someone connects to the host, I'll just send back the remote attestation back to the client. You might use a different kind of a mechanism to share the remote attestation, but it depends on you how you want to do that. The important thing is you need to verify the remote attestation and the measurement before you really send any confidential data to your enclave. So for the purpose of the demo, it's pretty much okay to send the information and then print it out here. So let's do a bid of 1,000. Right. So we'll wait for so this client has now sent the information, and it will wait for the response from the enclave. Now what I can do is I can send more bits using more clients. I'll start another client. And here's the second client. So this one, say we have bid for 2,000. And then let's go ahead and start one more client. Right. And here, say we bid 1,500. So what should happen is basically your winning bid should be the second one, which is 2,000, and your and the other two should receive a message that they have not been able to give the best bet, right? Or give the best bid. Now all this information is encrypted and sent to the enclave. Like I showed you on the program, nobody has a view of what the real bids are other than the one who's sending them. So now once you have a deadline has reached, or you're not you have your auction deadline, what we could do is you could have the admin send a message to the enclave to process the bids and send back the information. So what I'm doing is I'll run the client as an admin now. And when I run this client as an admin, this is what happens. So basically you say that the enclave has given a reply to the admin that the winning bid is 2,000, and to all the clients it would have given a reply of saying for the bid which was 1,500, it said better luck next time because this is not the best bid. And then for 2,000, it gave a reply, congratulations, you made the winning bid. that's the best bid, so obviously he wins. And then also for the 1,000, it was not the best bid, so he loses as well. So that's how we can send confidential information, and no one would be able to see it, even the machine that's running your enclave or the host program that is responsible for loading your enclaves and even sending information to the enclave, because it's considered untrusted at all times. All the information that is sent to and from the host is always encrypted. Host is just there to help you with any resources that your enclave needs. Right? And so that brings us to an end of this demo. And I'll just pause and see if we have any questions as such at this time. All right. I think there was just one question which I already answered.
That's right. And I guess that's about time that we have. So I would just like to thank you so much, Mr. Meher, for conducting today's masterclasses. Thank you to all our delegates for being with us, and we hope you all will stay with us till the end of the event. Another thanks goes out to our platinum partners, R3. Thank you so much, Ashutosh. Have a great day.
Thank you, Aparna, and thanks to the entire AMI team. All right. See you soon then. Bye-bye.
Bye-bye.